Good morning, lovely year 3 children. I hope you're okay and managed to get on okay with your maths work yesterday. Moving on again today, and this is probably something that you won't have done before. So you may have looked at right angles in shapes before, maybe looking at direction before in lower school. Today is moving on to a clear year 3 objective, which we'll go over in a minute. So let's get started with a quick 5 a day. You've got it saved in your OneDrive. I have got it up on my notepad here. Here it is, 5 a day. It's got today's date. There are your questions. Pause me for a minute. We've done this lots of times now. Please don't spend more than 10 minutes and be honest about what you know. And then when you're done, unpause me and we can go over the answers together. Good luck, everyone. Okay, so hopefully you've had a go at all of those questions for me. Remember, using a different coloured pencil to mark and move your normal pencil out of the way. If you didn't fill one in or you got one wrong, you change it in your coloured pencil so you can see what you got right and what you got wrong. So starting up here, use a ruler to draw a right angle. Now, if you don't get this right, I'm bamboozled because we have just done 3 days on right angles. A right angle, or we could call them perpendicular lines, look like that. And if you were really clever, you could have drawn in the gap there that little square. Oh, that's freehand. We don't want to be freehand, Miss Brogan. A little square going across there. And oh, that's not very straight either. Going down. Oh, make it straight. So hard on a computer to show my right angle. That's what it should look like. It doesn't matter if you've got it the other way around, if you've got it this way. It doesn't matter if you've been clever and you've done it coming from an angle like that. As long as it is a very clear right angle. Give yourself a mark if you've got that. I'm hoping you all got that right. I hope so. Okay, over here we have got double 2 times 8. Now you all know your 2 times tables. If you're working on your 8 times table hexagons, you could use your 8 as well, but I'm going to use my 2s just for everybody. So 2 times 8, you should know off the top of your head, is 16. So we've got the answer 16, but I don't want to know what the answer to 2 times 8 is. I want to know double that. So what is double 16? Now you could put another 16 underneath it and do it as an addition sum. You may have done that, or you may partition 16 twice. So you could do 10 and 10 and 6 and 6. So we know 10 and 10 is 20, 6 and 6 is 12. So that makes 32. 20, add another 10 is 30, add on the 2, 32. So if you've got the answer 32 in there, well done, give yourself a tick. Perfect. Right, let's go down here. Write down the value of the 2 in the number. See if you can say that number for me. It's a big number. Well done if you can. 5,267. Now, if you say the number, you get the answer to this question, because I know when I say it, 5,267. So the value down here is 200. You could have written it like this, or you may have written it like this, 200. Either way, it is correct. Give yourself a tick. Well done if you got that right. Okay, so I'm going to go over here first because we should also know this. We've covered this as well in our time work. It's good to revise some of the things we've been learning. How many days in March? I've got my knuckles out. I'm going to go to January, 31, because it's on my knuckle. February is the odd one out, remember, it's got 28 days. January, February, March is on my knuckle. What does that mean if it's on my knuckle? 31 days. So if you wrote 31 days in there, always good to write the units that you're measuring in. So I've written days afterwards because that's what the question asked, but 31 is right. There are 31 days in March. Well done if you got that right. Right, let's jump to this one. A quarter of 16 equals half of something. A quarter of 16 equals half of something. Now, this is really difficult. So the first thing we're going to do now, remember, if there is a calculation like this and it's got an equal sign, Otter's class, we've done this, equals means it's got to be the same on either side. So we don't want it to be unbalanced. It has to be exactly the same. We've got to balance it on either side. So the first thing I'm going to do is find out what a quarter of 16 is. Now, if I need to find a quarter of something, I'm splitting it into 4 equal parts. So I'm going to use my 4 times table and I'm going to count up until 16. 4, 8, 12, 16. A quarter of 16 is 4. So if you manage to get that side right, well done. That's not quite the answer yet, but a quarter of 16 is 4. And I can check that because I know 4 times 4, 4, 8, 12, 16. So that's that side. Now, half of something. A quarter of 16, which is 4, is half of something. See if you can figure that one out. What did you write in there? Tell me. Well, what would I need to find half of to have the same answer here? So what I could do with this is double this number. Let's try it. Let's try 8 and see if it works. Double 4 is 8. So a quarter of 16 is 4. Half of 8 equals 4. So if I put 8 in there, so a quarter of 16 is 4. Let me put an arrow down to show that that's what we got there. A quarter of 16 is 4. Half of 8 is also 4. So the answer you should have had in that little space there is the answer 8. That was a really tricky one today. We can do a few more of those to get our brain together. Well done if you got it right. So give yourself a mark out of 5. 1, 2, 3, 4, 5. No extras today. Please let us know how you got on because it's really important. These little 5 a days are revising things that we've done, challenging you a little bit to think about the things that you have learnt, but using them in a different way. So, for instance, using your times tables for doubling, using your fractions there to find a balance of a calculation there. So, yeah, it's really important that we do these to keep our maths brains going. Right, I'm going to stop the share for now. So our walt today, and I'm going to share a PowerPoint with you to go over this with you. And we've got a little video to watch as well, like we have done the last couple of days. So our walt today, let me get it up on the screen for you, if I can find it. It's always so difficult to navigate here. And I'm just going to go from the beginning. Bear with me. Here we go. Here's our walt. Our walt today is to recognise angles that are more or less than a right angle. Okay, and it's got 2 key words that we're going to know by the end of this lesson. We've got this word acute and we've got this word obtuse. Okay, so say it after me. Acute, obtuse. Just say it once more so you've got them in your brains. Acute, obtuse, okay, because they look a bit strange words. So just if we repeat them, sometimes it's easier for us to remember what they are. So more or less than a right angle. So we know what a right angle is. And yesterday we found out that it was the same as 90 degrees when measuring angles. It is a quarter of a turn also. So when we're looking at a clock, a right angle is when it's pointing to quarter past or quarter to, quarter of a turn. So yes, that's what we're going to do today. Now, I'm just going to stop this share for a moment because I would like you to watch the video clip that I have first, and then we'll come back to the PowerPoint. It is the same video clips that we have been watching. So I'm going to press play and it will go over a few of the things that we've already covered to do with right angles, but it does move on to what we need to know for today. So just have a listen to this.
Hello again. This is our second lesson about angles. We're going to learn a little bit more about right angles and look at some different types of angles as well. Here we have on the screen an angle. In fact, we've got 2 angles, haven't we? And there's one of the angles. The measure of turn, the measure of the gap between 2 lines. And we can see that's a right angle, and we've shown that with our special right angle symbol. And we saw yesterday in the previous lesson that in a full turn, there are 4 right angles, so a right angle is a quarter of a full turn. So, an angle is a measure of turn, and as we know, when we measure something, we use units, so we can measure length in meters. We can measure time in hours or minutes. So we measure angles. The unit we use to measure angles is called degrees. There are other units we use as well for angles, but the main one that we use all throughout school is called degrees. And there are 360 degrees in a full turn. Remember, there are 4 right angles in a full turn and 360 degrees in a full turn. So, your first task today, have a go at calculating how many degrees there are in one right angle if there are 360 degrees in a full turn.
Now, he will go over this with you. We have actually touched on this already yesterday. So 360 is the whole way around, one full turn. And we know that it's made up of 4 right angles, okay, just like you can see here on this picture here. So to find out what each angle is worth, we know that we have to do 360 divided by 4 because there's 4 of them. Now, we know this from yesterday, but he will go over it with you just so that there's a bit more clarity.
So that was our task. So we've got 4 right angles in a full turn, so we need to divide 360 by 4 because each right angle is of course equal to each other. So we've got 4 groups, 4 parts of that 360 degrees. So we may have used that known fact, that 4 times table fact, 36 divided by 4 is equal to 9. So 360 divided by 4 is equal to 90. So there are 90 degrees in a right angle. And that's really important that we know that about right angles. A right angle is 90 degrees. Why? Because a right angle is a quarter of a full turn, and a quarter of 360 is 90, and there are 360 degrees in a full turn. So here we've got a diagram showing 2 right angles. And as we learned from our previous lesson, 2 right angles are half of a full turn. We now know that 1 right angle is 90 degrees. So use that fact to calculate how many degrees there are in half of a full turn.
Now, we did this again yesterday, we touched on it very briefly. So if this one is 90 and this one is 90, what is half a turn? What degrees? Can you remember how we did it yesterday? You could do 90 add 90. Or you could use your 2 times table because we're doing 90 times 2. He will go over this with you in a minute. We know that 9 times 2 is 18, and we pop the 0 back on to do 90 times 2, making it 180 degrees. He'll go over that with you now.
So that was our calculation. We've got 2 right angles, so 2 lots of 90 degrees. So 90 multiplied by 2 is 180. So the answer is 180 degrees in a half of a full turn. You may have also thought, well, 360 is a full turn. What is half of 360? So that would have given us 180, which is half of a full turn. Finish these sentences that I've given you. You don't need to use numbers for them, you need to use words to look at all those 4 angles. What's to say about them all?
Okay, let's pause it there then. So let's look at these now. Can we see, are any of these here on the screen a right angle? What do you think? They are not a right angle, and I can see that because we're using the curved sign now instead of our little square, because the square shows us that it's a right angle. These 2 here are very close to being a right angle, but we know that the line has to go straight up here, and this one would have to come straight down here for it to be a right angle. They're very close, but they're not quite. So let's have a look at this sentence. All of the angles are something a right angle. What could we put in here? What word could we put in here? Well done if you got it. All of these angles are less than a right angle. Okay, they're all smaller than a right angle because I'd have to move this up here for it to be a right angle. I'd have to move this line here, and these ones here, these lines are much smaller than a right angle. You can see they're like squashed right angles. Right angle, less than a right angle. Right angle, less than a right angle. Right angle, less than a right angle. Can you see? Right angle, less than a right angle. Okay, so all of the angles are less than a right angle. So all of the angles are less than 90 degrees. There's our 90 degrees, less than 90 degrees. Okay, try and imagine it when you're doing it. Use your hands. It's always good to have a visual. Right angle, less than 90 degrees. Okay, 90 degrees, less than 90 degrees, less than 90 degrees. All of those angles, as you close this, what looks like a crocodile's mouth, all of them are less than 90 degrees. I'll put it back on.
So hopefully we can see that all of the angles are smaller than a right angle, or you could put less than a right angle, that would have been fine as well. So that means all of those angles are smaller than or less than 90 degrees. And we call angles less than 90 degrees acute angles. So we've got two types of angles now. We've got right angles, and right angles are exactly 90 degrees. 91 degrees isn't a right angle. 89 degrees isn't a right angle. In fact, 89 degrees will be an acute angle, because angles that are less than 90, so between 0 and 89, or between 0 and just before 90, are called acute angles. So
I'm just going to stop there. He may say this in the video in a moment, but this word acute, if I made this into two words, acute, like a cute dog or a cute puppy or a cute kitten, makes me think of something small. So that's how I remember acute angles, because if we say that they are acute, it means that they are smaller. So if you remember that, if we talk about something that's being cute, a cute little girl or a cute little boy, we're thinking about something small. And so if you remember that, you will remember that acute is smaller than a right angle. That's how I remember it. That might help you to remember it too.
Sometimes people remember that by saying, well, cute things are often quite small, like babies. We say babies are quite cute, or puppies are quite cute. So they're small people or small animals. So acute angles are small angles, less than 90 degrees.
I agree.
4 more angles for you to complete those sentences for.
Okay, so let's look at these ones now. So if we're going to look at the right angle now, if I look at these ones now, I'm going this way. In fact, I'm not going to be able to stretch for some of them because my wrists won't go that far. But you can see, so what do you think we could put in the sentences this time? We know that they're not right angles because we've got this curved edge again, and a right angle we do with a little square box shape. So what would I write in here now? Well done. All of the angles are more than or bigger than a right angle. All of the angles are bigger than 90 degrees.
So hopefully you put something about all of the angles are larger than a right angle, bigger than a right angle. I put greater than a right angle. As long as you've got a word in there that shows that you understood that all of them are larger, greater, bigger than a right angle. So that means all of these angles are, again, we could have more than, greater than, bigger than, and so on, 90 degrees. So these angles are called obtuse angles, because we can see that they're more than 90, but they're less than 180. And the dotted lines show the 180 degrees, which remember is half a turn. So they're between a right angle, 90 degrees, and half a turn, 180 degrees. So they're called obtuse angles. So we've now got 3 types of angles. Acute angles, the smallest ones, less than 90 degrees. Right angles, exactly 90 degrees. And obtuse angles, so they're bigger than a right angle, greater than 90 degrees, but less than, smaller than a half a turn, smaller than 180 degrees. Have a go at putting angles A, B, C, and D into the correct columns on the table.
Okay, so looking at this, we've got acute, right angle, obtuse, or other angle. Okay, so let's look at A. Anybody have a clue here what this A might be? Well, we've got a really good clue, haven't we? Because we've got that little square in the corner. That would go in right angle, so we could put the letter A in here. Okay, let's look at B. This is a large angle here. It's on the outside, this one. How strange, it's on the outside. We'll come back to B. Let's have a look at C. So I can see here, there's my angle on the inside of those 2 lines, and it's looking rather like this, which makes me think that that one, C, would be an obtuse angle. It is bigger, larger than a right angle. And then when I look at D here, it's like that one that was really close to being a right angle, but it's in a little bit like that. So we know that that's cute. It's an acute angle. Now, because this one is on the outside of the shape, I'm going to say that that angle needs to go in other, because it's not on the inside of where the lines are, in the inside of the shape, it's on the outside. Let's have a look.
Hopefully angle A was really easy because we've got the special symbol for a right angle there. So angle A is a right angle. Angle B, well, that is in fact larger than an obtuse angle, isn't it? Because we can see it's more than half a turn. So angle B is an other angle. It does have a name. We'll learn that later. So angle C. So C and D, of course, some people would think, oh, D is a bigger angle, a greater angle, a larger angle, because it's got the lines are longer. But remember, the size of the angle is nothing to do with the size of the line. It's to do with the gap, the size of the gap, the size of the turn between the two lines. So C is the larger angle than D. So C is an obtuse angle because it is less than half a turn. It's less than 180, but it's definitely more than a right angle. It's more than 90. And D is an acute angle. You can see it's not much less than 90, but it is less than 90 degrees. So you are familiar with the inequality signs. So use those inequality signs there to compare, or of course the equal sign, to compare those pairs of angles.
Okay, let's have a quick look at this together. So we've got the greater than and less than and the equal sign. So here we've got a right angle, which is 90 degrees. And we can see this one here is less than, isn't it? It's smaller than a right angle. It's an acute angle. So I would have my symbol, I would have less than, pointing this way, the crocodile mouth there, less than. So it would read like this. This right angle is more than this acute angle. Let's look at this one here. Oh, they're very close. These are both obtuse angles because they are more than a right angle, more than 90 degrees. But this one is actually smaller again. So I would have my sign in, my sign this way, the crocodile mouth shut facing this way. So it would read, this obtuse angle is smaller than this obtuse angle. Okay, down here. Oh, this is difficult as well. So we've got this angle here, which is an acute angle because it's smaller than a right angle. And then we've got this one here, which is bigger than a right angle. It's on the same shape. On the same shape, two different angles. So this one is obtuse, so it's bigger. So my crocodile would go that way. And it would be, this acute angle is smaller than this obtuse angle. And then we've got two right angles, look, we can see by the symbol. So what would I put in here if they are both the same? Well done, we put the equal sign. This right angle is equal to this right angle because they are both 90 degrees.
Number one, we can see on the left we've got a right angle.
We'll just check it over.
On the right we've got an acute angle, even though the acute angles lines are quite a bit larger than the right angle. That doesn't matter, we're looking at the size of the angle. So we know a right angle is larger than an acute angle. So there we have that inequality sign. Number two, we can see we've got two angles that are both greater than a right angle, but I think the one on the right is quite clearly, the gap is wider, isn't it? The amount of turn is more there on the right hand side. Number three, we've got the same two sets of lines there on the left and the right, but the angle shown is different, isn't it? On the one on the left, the smaller angle is shown, and on the one on the right, the larger angle is shown. So the angle on the right is larger. Those two angles added together would be half a turn, wouldn't they? So they'd be 180 degrees. And number four, well, the angles look quite different. They're in a different way around and things, but we can see that special right angle symbol is there for both. So they are equal to each other. They're both right angles. Some sentences for you to complete, thinking about what we've learned, the different types of angles we've learned about in this lesson.
Okay, we'll go over these together as well. So there are how many degrees in a right angle? Well, you should know by now there are 90 degrees in a right angle. An angle which is something than 90 degrees is called an acute angle. Was that more or less than 90 degrees, an acute angle? Well done, is less than 90 is called an acute angle. An angle which is more than 90 degrees but less than 180 degrees is called an, well done, obtuse angle. There are how many right angles in a full turn? Can you remember how many right angles were in a full turn? We did this yesterday as well. 4 right angles in a full turn. And then in a full turn, can you remember the degrees in a full turn? It's quite a large number. Well done if you remembered. 360 degrees in a full turn.
So our key fact is we've got degrees that measure angles. They're the unit of measure for an angle, and there are 90 degrees in a right angle. And an angle which is less than, you could have put smaller in there, less than 90 degrees is called an acute angle. An angle which is more than 90 but less than 180, so less than that half a turn, is called an obtuse angle. And that's really important. It's not just that it's bigger than 90, it is greater than 90, but it is between 90 and 180, between a right angle and half a turn. How many right angles are there in a full turn? There are 4 right angles in a full turn. And how many degrees are there in a full turn? Well, if there's 4 right angles and each right angle is 90 degrees, there are 360 degrees in a full turn.
Okay, I'm going to stop the share there. I'm hoping that you've got quite a lot of information from that. They're really good videos from White Rose Maths, which you can also get online. If you put it into Google, White Rose Maths, there are some free videos that you can watch online, which are really, really good. And there's actually some activities with them as well. I'm going to share with you a quick PowerPoint before I show you your activities for today. So it had our walt at the beginning, there it is. And now we've learned what these words mean. Acute, meaning smaller. Obtuse, meaning bigger than a right angle, but less than 180. Okay, so let's have a quick flick through here. An angle measures the amount of a turn. We learnt this yesterday. There's our right angle turn, 90 degrees. That's our right angle. Anything within this space, within here, we would call an acute angle. So if I drew a line going up here to make an angle here, it would be an acute angle. Anything within this space here. There's 180, that's our straight line, our half a turn. Anything between here, this whole space, but not more than 180 would be our obtuse angle, our larger than 90 degree angle. So it has to be more than this one, but less than this one. So if I drew a line here, all of this here, that angle would be an obtuse angle. Okay, so let's have a look at it on a straight line like this. So this is kind of like looking at half of a clock, I would say, the top half of the clock. So here is an angle, here's our 90 degrees, and there's a line been drawn in here. So is this line smaller or bigger than 90 degrees, this angle in here? It's less than 90, so it's an acute angle. There's another one that is still less than 90, look, so it's still an acute angle. There's another one, it's still less than 90, so it's another acute angle. Okay, on this side as well, so we've still got between 0 and 90. All of these in here are going to show me that they are acute angles. Okay, because they measure between 0 and 90, they're in between. Now, the difference between these two pictures is this one's got the 0 on this end, between 0 and 90, and this one's got the 0 on this side, going 0 to 90. It doesn't matter which side, all of them are within that quarter turn, meaning that they are less than a right angle, less than 90 degrees. There's our right angle on there. These are right angles and they measure exactly 90 degrees. We know that, we've learnt that in the last few days. Now we've got 0 all the way to 180 here now, and this one's doing it the opposite way round. So these are going to represent our obtuse angles, look, because if we go from 0 all the way around here, so my angle would go here, this is more than 90 degrees. So is this one, because here is my angle here. And so is this one. Here is my angle. So it's more than 90 degrees. It's on its way to 180, but it's not more than 180. These are my obtuse angles. Can you see there? They're quite large angles, look, represented on that picture. Same here, except it's the opposite way around, just showing you can see it in a different way. These angles are obtuse angles. They measure between 90 and 180, which we've just gone over. Now, these pictures I'm just going to quickly show you are angles that you can find everywhere, and you're going to need some of these ideas for tomorrow. So I thought I'd just quickly show you some of these ideas. You can take photographs or draw pictures. Photographs are brilliant, actually, because when you print them off on the computer, you can add a red line in here. Look, so this lady here, taking a picture of the door, and she has found 2 right angles hidden in the door. Look, in the door frame, 2 right angles. Then she's looked at some bricks and she's found right angles hidden inside the bricks. Another good way of looking for angles around our homes and in our gardens. There's another right angle, look, hidden at the top of the fence there. Now, if we look carefully in nature, lots of angles to look at. Look, here's an angle. Can you see it here? Look, it's not a right angle this time. It is smaller than a right angle. Remember, the smaller ones are called acute angles. So she's found an acute angle there on the branches of this plant. And there's another one there, slightly smaller than a right angle, another acute angle. There they are, hidden within nature. Now, she's found another one in her garden. Now, I'm going to point it out to you here. See this one here? This is an angle. Is it bigger or smaller than a right angle, do you think? It's bigger than a right angle, making it one of our obtuse angles. So they're hidden everywhere, all round, on the fence. Or look there again. That is bigger than a right angle. It's an obtuse angle. So that's just showing you that you can find all these angles everywhere. Oh, there's another one in between her washing line, I think it is. It's smaller than a right angle. It's an acute angle. And another one there, another acute angle hidden on her washing line. A picture of a star. It looks like it might be on some kind of wooden frame. An acute angle hidden. So in fact, there's lots of acute angles hidden in the stars there. But it's also got an angle here, this side, which is more than a right angle, an obtuse angle. Oh, I'm going the wrong way. There we go. So that was just some examples that I thought would be helpful for you to see, that you can see them all the way around your home. So let's get cracking today. So our key facts are: a right angle is 90 degrees. An acute angle is anything less than 90 degrees. An obtuse angle is anything more than 90 degrees, but not more than 180. And 180 is our straight line. What you're going to do today for me is you're going to see if you can identify those 3 different types of angles. So I'll get my share screen up again. Let me see if I can find it. Where is it hiding? I can't find it. Let me just pause. There it is. So still hexagon, squares and circle work. So hexagons, there's your work there. It's got the walt on the top, the same as what we shared. It says here, label the angles 1 to 15 as bigger than, which is obtuse, smaller than, which is acute, or right angles. So label them underneath all of these angles 1 to 15. What you think. So you can put in the curved angle edge inside, or if it's a right angle, do you want to give you one here? You can put in the little square to show it, okay, and shade it in so I can see that you've seen whether they're bigger or smaller. And then just underneath, write whether it's obtuse, acute, or a right angle. If you want to write bigger than a right angle or smaller than a right angle, you can, but the mathematical terms are obtuse and acute. So I'd really like you to try and use those, even though for year 3, really, you just need to know whether it's bigger or smaller. Then down here it says, use your right angle checker. I'm going to tell you about that in a moment, to find out how many of each type of angle there is in the shapes below. So you've got 6 shapes here. So here is shape 1 here. Now an angle checker, and you're going to do some of this tomorrow, is just really the corner of a piece of paper. Because you will have printed this off. Just use the corner, and I'm going to make it quite small. I've just got a scrap piece of paper in front of me. See this here, this is a right angle, and if I hold it up against the shape, if it fits in perfectly, and you'll need to do this tomorrow as well, if it fits in perfectly, then it's a right angle. If it fits right into the corner perfectly. So if I use a book here, here's a book, and you're going to do this tomorrow anyway, and then I get my right angle checker. If it fits perfectly into that corner, then I know it's a right angle. So you can do that to do the to use on these shapes here. So number 1, how many right angles? So you use your knowledge of right angles. Are there any in there? Any angles that are bigger than a right angle? How many are smaller than a right angle? So that's all for shape number 1. Then you do the same for number 2 down here, the same for shape 3, the same for shape 4, the same for shape 5, and the same for shape 6. So you're counting how many right angles, how many bigger than right angles, how many the smaller right angles, and filling out that grid there. So that is the hexagons work there. It's a lot to get on with today, hexagons. Squares, you've got lots of angles on here, and I've given you a little key to start off here, and it says acute angles are less than 90. Obtuse angles are less than or more than 90. Okay, so I want you to underline which one is correct. Acute angles are less than or more than 90 degrees. So circle the one that's correct. Obtuse angles are less than or more than 90 degrees, but less than or more than 180. So circle what makes that sentence correct for me first. Then it says choose 3 colours and fill in the key. So any 3 colours for these. So let's just pretend it's red, blue and green. And then when you're looking at all these angles, you're going to colour the angle symbol either red, blue or green to represent it being an acute angle, an obtuse angle or a right angle. So squares, that's what you're doing today. Circles, you, let me just make this a bit smaller, have got these shapes here, and this one I've done for you. Colour in the angles of each shape, blue for right angles, red for acute, which is smaller than the right angles, and green for obtuse. So remember, if it's acute or obtuse, you use that curved edge to show a right angle. I'll just show you that on the square sheet like this. If it's a right angle, you use the little box like the same as we did yesterday when we were, and the day before, looking for right angles. So you've got 3 colours that you need to show on here. And then it says at the bottom, how many right angles are there? So count all your blue right angles. How many obtuse angles are there? So count all of your greens. How many acute angles? So count all of the reds that you made. And how many angles altogether? That's counting all of the angles that you found in the shapes, circles. If you manage to get all that finished, your extension today is a bit like, I'm going to say it's a little bit like a test question or 2 test questions. So it's using a clock here, which I think is a really good one. So it's looking at the lines of a clock and it's asking you to say whether the lines are showing the space in between those lines. Is it a right angle, an acute angle, or an obtuse? So you write right angle, acute, or obtuse underneath each clock. Then it says complete these sentences. An angle less than a right angle is called a something angle. An angle greater than a right angle but less than 180 is called a something angle. Label each of these angles as an obtuse, acute, or right angle. And in your book, draw and label your own angle. So you could have a go at drawing your own angle if you wanted, but answering those first. So you've all got a worksheet and you've all got an extension to get on with. Now today, this work is your assessed piece of work. This is the work that I'm going to mark. So you have got until tomorrow. No, sorry. You've got until Friday to make sure this is in for me. I was getting mixed up with the days there. So until Friday. So if you don't get it all finished today, please make sure it's in to me by 3 o'clock on Friday so that I can mark it and get it sent back to you. And that includes the extension as well, because we can see what you've done. And it's really important, year 3, that you really try your hardest to do this on your own. Because we're marking it for you, we want to see what it is that you're capable of. And so if you've had quite a lot of help and then you get it all right, it makes us think, oh, they know exactly what they're doing. But if you've done it on your own and you make a few mistakes, we can say that you need some more help with acute angles, or you need some more help with obtuse angles or right angles. So please be honest with your work. And parents, I know that's difficult sometimes. So a little bit of guidance is fine, but mainly independent if you can. So that's your activities. I have talked quite a lot at this, on this lesson. So I hope I haven't confused you too much. Good luck with it all. Remember, right angle, 90 degrees, acute angle, very cute, less than 90, obtuse angles, more than 90, but less than 180. Good luck, everyone. I can't wait to see your work.